Hey everyone, welcome back to another hands-on Python tutorial for beginners. In today's video, we're diving into one of the most classic and beginner-friendly sorting algorithms out there, the legendary bubble sort. Here's the plan. We'll start off with a formal yet simple definition, take a look at the algorithm's pseudocode, walk through a step-by-step example to really understand how it works, and then we'll write the actual Python code together. We'll also break down its time and space complexity in a way that makes total sense. So stick around. It's going to be fun and crystal clear. Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. This process is repeated until the list is sorted. Think of it like this. It keeps pushing the largest element to the end of the list, just like a bubble rising to the top of water, one step at a time. This bubbling up continues until everything is in the right place. It's not the fastest algorithm in the world, but it's a great one to start with, especially if you're just learning how sorting works under the hood. Now let's take a look at the pseudocode for bubble sort. We run a loop from I equals 0 to n minus 1, where n is the length of the array. Inside that, we run another loop from j equals 0 to n minus I minus 2, and compare array element at j and array element at j plus 1. If the first one is greater, we swap them. Let's now connect our formal definition to this pseudocode. How does each part of the definition turn into code? Step through the list, translate to the code. For I from 0 to n minus 1. Compare adjacent elements, list, translate to the code. If array element at j greater than array element j plus 1. Swap if in wrong order, translate to the code. Swap array elements at j and j plus 1. Repeat until sorted, translate to the outer loop that runs n times to ensure full sort. So you can see each sentence in the definition maps directly to one or more lines of the pseudocode. Let's sort this array step by step using bubble sort. We'll go through each pass, compare adjacent elements, and swap if needed. Bubble sort works by repeatedly pushing the largest value to the end of the list with each pass. Pass 1. Compare 51 at index 0 and 32 at index 1, 51 greater than 32. So swap these two elements. Compare 51 at index 1 and 10 index 2, 51 greater than 10. So swap these two elements. Compare 51 and 18, 51 greater than 18, so swap these two elements. Compare 51 and 21, 51 greater than 21, so swap these two elements. Compare 51 and 6, 51 greater than 6, so swap these two elements. Largest element 51 is now at the end. Pass 2. Compare 32 and 10, 32 greater than 10, so swap these two elements. Compare 32 and 18, 32 greater than 18, so swap these two elements. Compare 32 and 21, 32 greater than 21, so swap these two elements. Compare 32 and 6, 32 greater than 6, so swap these two elements. Second largest 32 is now in place. Pass 3. Compare 10 and 18, already in order, do nothing. Compare 18 and 21, already in order, do nothing. Compare 21 and 6, 21 greater than 6, so swap these two elements. Third largest 21 moved to its correct position. Pass 4. Compare 10 and 18, already in order, do nothing. Compare 18 and 6, 18 greater than 6, so swap these two elements. 18 bubbled up. Pass 5. Compare 10 and 6, 10 greater than 6, so swap these two elements. 10 in correct place now. Pass 6. Compare 6 and 10. Already in order, do nothing. Since no swaps were needed, the array is fully sorted. Alright, now let's write the bubble sort function in Python, step by step. We start by defining a function called bubble underscore sort, and it takes one parameter, the array we want to sort. Next, we store the length of the array in a variable called n. This tells us how many elements are in the list. Now, we write the outer loop. This loop will make n passes through the array to ensure everything is sorted. Inside the outer loop, we add an inner loop. This loop helps us traverse the array and compare adjacent elements. Notice how we go up to n minus I minus 1. That's because after each pass, the biggest element is already at the end and doesn't need to be checked again. Also, please note that range does not include n minus I minus 1, and therefore it runs till n minus I minus 2, as specified in the algorithm. Next, we compare two neighboring elements using an if statement. If the element at position j is greater than the one next to it, we swap them. Here's the swap. This single line exchanges the values if they're out of order. And that's it. The array gets sorted in place, meaning we don't need to return anything from the function. Now let's test our function with an example. We create a list called input array with some unsorted numbers. Then, we call our bubble underscore sort function and pass the array as an argument. Finally, we print the sorted array using a print statement. Run the program, and the sorted array is printed to the output. Let us change the array and rerun the program. Sorted array is printed to the console output. Time and space complexity. Now let's talk about how efficient bubble sort is. Worst case scenario, when the list is in reverse order, O of n square. Best case scenario, when the list is already sorted, O of n. Average case scenario, when the list is in random order, O of n square. There are n passes, and each pass compares up to n minus 1 elements. That's n times n minus 1 comparisons, which is why it's big O of n square. Space complexity is big O of 1, since sorting happened in place without using extra memory. To summarize, we defined bubble sort, wrote pseudocode and connected it to the definition, walked through an example step by step, wrote the Python code, and discussed its time and space complexity. I hope this made bubble sort easy to understand. Try it out with different arrays and even add a step counter or debug prints to see what's happening under the hood. If you found this helpful, give it a like, subscribe for more beginner Python tutorials, and let me know in the comments which algorithm you'd like to see next.